Thanks, Sally. This thing's in the way, can't read that.
Yes.
I was just thinking, so one of the early rain advantages, really the good example would be Rhizoctonia. If you had Rhizoctonia from last year, obviously in a cereal paddock, it would have ramped up the inoculum levels quite significantly. And then with the rain, the early rain, and obviously good weed control, the inoculum reduces quite substantially. So it's a good example of using the environment to help you get on top of what's in your paddock. Now you'll notice the blue line there is canola. So canola is, let me remind you, a good option to control your Rhizoctonia levels. Now obviously the next opportunity for other diseases to announce themselves is as the season starts. So most of you would know, biomass is quite obvious above the ground, but there's also biomass below the ground. So more roots can mean more opportunities for root lesion nematodes, Rhizoctonia, crown rot, and tegal to start festering away at those healthy roots that are growing. Just an example to show you what would have happened this year. And I'm going to use crown rot as an example. Crown rot survives in stubble from previous years in cereal crops. It also will survive in any volunteers and weeds, grass weeds that are growing in the crop. So with the start of the season, there was plenty of rain to go around. So wet seasons really favour the infection process. And so this year, obviously, with the good rain, we would have definitely had plenty of that, and obviously a lot more crop and biomass, so more chances for the different stubble, the different tillers to get infected, so leaving a lot more inoculum for next year. Now, as you probably would know, end of the season really dictates the yield loss. So this year, in most cases, we had good rain also in the end of the spring, and so there probably would have been fairly limited disease expression and hence yield loss. The other part of that equation is when there's water stress and heat, which drives the expression of the disease and the yield loss. Now, there obviously were examples of some whiteheads around this year, and some of that probably would have been because of the high biomass and maybe some of the plants not being able to get enough water to all of the heads that were maturing. So there were definitely whiteheads out there. The other thing is, of course, compacted areas and other issues that reduce access to water. Crown rot is fairly widespread, but I just wanted to show you that crown rot obviously will be pronounced in areas in the low rainfall zone, but they certainly do appear or are in stubble in the southern areas of WA. Now, what this shows is actually the amount of stubble that's been infected. So the red ones are where stubble had more than 25% of crown rot in it. So you can actually use, if you're worried about paddocks that are potentially at high risk for crown rot and you haven't actually checked or you haven't seen any whiteheads, you can go and collect some stubble and about 50 to 100, and then if they fit in these categories, so anything above 25 will be high risk for next year. But you can see medium is 11 to 24% of the stubble infected. So you just look for the basal browning on your stubble. There's certainly quite a lot of water to go around, and this is my trial at Muresk. but I saw quite a few in the southern district that had a lot of water, and it does obviously cause some issues for the roots. This is a physiological symptom, quite pronounced, a reddish brown, but diseases obviously can get in too. What they actually do in this situation is something we need to investigate a lot more. The other issue with a lot of water does mean that things like root lesion nematodes and also other pathogens like the Phytophthora, which is an oomycete, can have the opportunity to move around the paddock as well. Now, Phytophthora, you say? Okay, so some of you in this room probably have provided samples to Carla Wilkinson, Lupin samples in 19 and 2020. The idea is to isolate a range of different pathogens from these lupins, and we did find a number of different things, including a range of Phytophthora. So there's 3 Phytophthora there. Dressroli is one of them. This particular pathogen is not a fungus, but it is related to the fungus. It can survive in thick-walled spores, which are oospores, for quite long periods, but it does produce on the right-hand side, you can see a sporangia with those zoospores, and they actually have like flagella which can propel them around, and they swim towards roots and find their target. So quite a nifty little pathogen, and they can actually have quite a big impact, although we're still trying to establish what they're doing and trying to isolate them. And this is what we're doing. This is what we were doing earlier this year. This is a lupin paddock in Kojonup, and you can see Carla there standing in a number of patches there that we were seeing in these lupins. And so from that, we're trying to isolate, I guess, a pathogen or a few pathogens. And we have already got a few different potential ones that we're going to sequence over the next few weeks. This is actually the same paddock, and you can see when you eliminate, so the previous one actually had quite a bit of water in it before. This, when you rip it and eliminate that water equation, you can see it's really reduced the effect of the symptoms that you saw in the other slide. And potentially things like Phytophthora with water not there are not able to infect and spread. Now the other issue, as Catherine mentioned, is herbicide control. And obviously break crops, if they have grasses in them, are obviously going to increase your pathogens and nematode pests quite substantially. So a break isn't a break if there's a lot of weeds there. And we did see quite a lot of these paddocks end of the season. So looking into 2022, so potentially there are quite a lot of paddocks with a fair amount of inoculum of different pathogens and nematode pests. And then it obviously depends on what you plant next year. If it's a cereal or another susceptible crop and the environment aligns with the pathogen, then you potentially will run into a lot of disease for 2022. So this is actually showing crown rot, so you can see the pink fungus up the top. If you sow it a wheat and the conditions start with a nice rainfall event to drive infection, and then end of season is a very dry spring during grain fill, you can end up potentially with quite a lot of yield loss. Just going back to this crown rot life cycle, so for 2021, potentially there are paddocks with a fair amount of inoculum that have been generated over this year with all the start of season rains. And depending on the season for next year, if it ends with a very dry finish, you could end up with a lot of paddocks with whiteheads. we have been here before. Remember back to 2013, it was quite a wet spring, and that was followed by a fairly dry, sharp finish, and we had a lot of crown rot out there. So don't tell me I didn't warn you. And just to finish up, I can see there's a Soils West stand at the back. That's the QR code for the soil biology one, which I was involved with, and Sarah. So we put a lot of our resources into soil-borne diseases, as well as the good guys as well. If you're interested, it's free, and you can download it on your Apple device. Thank you.
Thanks, Daniel. I think we go straight... Oh, no, we don't. We go into... Are there any... The latest question... Okay, one question... Where are we?
I can't read it from here.
Thanks to ripping, soil amelioration to improve disease control. How important is soil amelioration for this?
That's a good question. So I guess I didn't have time to go through all the amelioration work, but we've got a number of different projects looking at that, including trials which have ripping and morbore ploughing, which is obviously the extreme, and we have found that it obviously changes the soil dynamics, but also the where the pathogens sit and how they infect. And a couple of, like the morbore plough especially, we did get reduction in infection for Rhizoctonia and root lesion nematodes as well. I think I'll leave it at that one.
Okay, thanks. Thanks, Daniel. So there'll be a chance at the end after Geoff is our last speaker of this session. So Geoff Thomas, pathologist based in South Perth. We'll have about 15 minutes for questions. So start doing your Slido or think them up so that you can put your hand up when and everybody will be back to ask. You can ask any of the questions. Thanks, Geoff.
That's assuming I stick to time, Sally. Thanks for coming along, everybody. Look, I'm going to talk a little bit about, the title says above ground diseases in a wet year. I could talk about almost everything out of this year, but I'm not going to. I'm going to try and centre in on a couple of things that I think were interesting this year and maybe have implications for coming seasons. So I'm going to talk a little bit about Lupin sclerotinia, and I'm going to talk a little bit about cereal rusts. So we are at DPIRD West. We've started this year working on a new GRDC funded project looking at sclerotinia management in narrowleaf lupin crops. This is a project that's led by Kira Beard out of our Geraldton office. I'm not Kira, you might notice. Unfortunately, she couldn't get here today. I'm part of this project, so I'm presenting on her behalf. We're working with the CCDM and with Minginoo Irwin Group, particularly on issues around sclerotinia. And the other thing that we're doing, obviously, is linking in with industry, with you guys, looking for opportunities to make observations or look at opportunities to do trials in paddocks. So certainly we've had plenty of input this year from industry in that area. We've heard all about the year, you know, it was wet and then it wasn't, and then it was wet and it was... but how did that impact on lupins? Well, it was a wet growing season. We had plenty of good early sowing opportunities, dense, good yield potential crops. So one of the things I noticed this year was that a lot of lupin crops, most of the seed came up, and so we often had lupin crops with quite high densities. And so particularly in the south, I was looking at crops with 50, 60 plants per metre squared, which is a very thick lupin crop. The other thing maybe that we saw this year is that with those dense lupin crops, with that wet July-August period, is that we had early canopy closure, quite a lot of that lupin, that leaf mulch underneath the canopy, and wet soil surface. Whether or not that was the contributing factor, but certainly we saw a lot of basal sclerotinia this year in lupin crops, particularly in that northern growing region, but we did see it, quite interestingly, extending further east than we might normally expect to see the impact of Sclerotinia and lupins. And so that was a bit of a new thing for us, the amount of basal Sclerotinia that we saw. So if we just have a look at how much Sclerotinia was around, in the Geraldton Port Zone, Keira and Anne surveyed 26 lupin crops. Every one of those crops had Sclerotinia in it, basically. So 100% of crops had some degree of Sclerotinia in them that they surveyed this year in that Geraldton Port Zone region. Interestingly, 85% of those crops, I think it says 85% of those crops had some degree of basal Sclerotinia. Now, I've been working in lupins for a long time. That was a big surprise to me, that the amount of crops that had basal Sclerotinia and the degree of which there was an impact. More than 80% of them had that more classical, upper stem, main spike infection, which is what we're more used to seeing. And Keira has said to me that there's been a couple of examples of loads being rejected by CBH4 having too many sclerotes in the load. So certainly there has been an impact. We've also got a little node of activity down in the Albany Port Zone, down around Kojonup, and we surveyed about 10 crops, 10 commercial paddocks this year down there. Again, Sclerotinia was in about 7 out of the 10 crops, so not quite as common, but I mean, it's only 10 crops. But the incidence and the severity of Sclerotinia, generally speaking, was less than in northern crops. We saw a couple of crops with 10 to 20% of plants affected, but generally speaking, we had to look for Sclerotinia to find it. As I said, if you have a look at that photo on that side, on whatever side that is, that's a under the canopy shot of a crop at Kojonup, and the stems are like hairs on a cat's back, basically. It was really thick, and we get this basically a carpet of green across the top of the crop. So what we were seeing with diseases like Botrytis grey mould actually was almost as common in those crops as Sclerotinia was. Late brown spot from all the falling leaflets onto the stem. So those thick crops, maybe Sclerotinia was one of a number of diseases. One of the drivers, we think, for the difference between maybe that southern region and the northern region is obviously temperature. And so these are soil temperature probes, and it's just basically at trials in Kojonup and in Geraldton. Basically the soil temperature at Geraldton was 4 to 10 degrees warmer throughout that growing period. I think that what that's going to end up saying is that it's not that Sclerotinia is not present. In our trials at Kojonup, we had petal infection at every order of branching on our lupins, but we just never got that progressing into disease. And I think that lower temperature is certainly one of the things having an impact on that. I just want to show an example of one of the worst paddocks we went to this year. So this is a paddock in the Wongan Hills district, early October, durian lupins, just about to go into leaf drop. And when you look out across the paddock of what at this time should be that beautiful yellow-green colour, there's a hell of a lot of these early senescing plants. And pretty much 50% of the plants had Sclerotinia of some sort in that paddock. And you can see from the one I'm holding up there that it's got basal infection, upper canopy infection. So 15% of the plants had basal infection in that paddock this year. And certainly, whilst this is one of the worst I've seen, it wasn't unusual to drive past lupin crops and see those early senescing plants, which often had basal Sclerotinia. The impact of that, well, you can see that, basically it was about a 50% reduction in the number of pods between the healthy and the unhealthy. You're going to say to me, what do we do about that, Geoff? The answer is, I don't know. There is nothing registered for basal Sclerotinia. It's hard to imagine that anything we might apply as a seed dressing will provide a long enough period of activity to protect those plants. It's something that we are going to be looking at as part of our ongoing research with this new project. I just wanted to quickly touch on the I mean, that's a massive reduction in pod numbers. We've seen that before in trials, but it doesn't always relate to that level of yield response. So last year, Kira had 3 sort of replicated demonstration trials in the northern ag region where growers put on a spray at about that early podding, late flower, early podding time, and we saw significant differences in pods like we saw in that trial, but about a 3 to 5% yield response to fungicide. Now, I'm not saying that necessarily, this year I think Sclerotinia has been worse, but certainly it does appear in lupins often that the visual impact is maybe greater than the response to fungicide. And maybe in these cases we were a little bit late, or maybe in these cases there was a requirement for a second application. And then the economics of that becomes interesting. So I'm not going to go, I'm going to finish there on Sclerotinia, but I just wanted to make the point that why am I talking about this in terms of this year to next year? Well, obviously, this year, lupin paddocks are going to be generating a hell of a lot of sclerotes into the landscape. So next year, or the year after, if you're putting canola onto that lupin stubble, certainly that is going to have a significant impact in terms of the sclerotia being carried in that soil. I'm going to change speed totally. I'm going to move away from lupins. I briefly want to touch on cereal rusts. I was interested to see the sort of age demographic because I'm not sure how many of those 20 to 30-year-olds have had a lot of experience with cereal rusts. This year, reports of leaf rust in wheat, leaf rust in barley, leaf rust in oats, stem rust of oats, and as Dion mentioned, stripe rust of wheat. I got pretty excited about that, I must say. Not surprising, I guess. We do a green breed survey every year. This year, the majority of paddocks that we were looking at in April and May, they'd been sprayed out, or for various reasons. But there was plenty of green paddocks with regrowth in it, and also there was plenty of green. The other thing we noticed, there was already plenty of wild oats along the side of the road, and it wasn't hard to find leaf rust on that wild oats at the start of the season. So we were pretty conscious of the fact that there was going to be the opportunity for some rust around. So just not necessarily that we had major issues with leaf rust in oats this year, but just to give an example to you to remind you of the damage that rust can do. So this is a trial run by Kylie Chambers at DPIRD down at Manjimup, oat leaf rust, 3 varieties, Carolup, which is susceptible to leaf rust, and then Mulgara and Williams, which are moderately resistant. The 2 take-home messages out of this. Firstly, if you have a look at the Carolup, you can see basically we've had a 50% yield loss in that trial. So from the full control to the untreated, 2 tonne yield loss. Just pointing out again the damage that rusts can do. Okay, and so again pointing out the value associated with responding early in the presence of rust in susceptible varieties. But the other, and to me probably the more interesting piece on this graph is actually the lack of response in the Mulgara and the Williams. And certainly I had calls or comments this year from industry saying, well, the Williams had a bit of leaf rust in it, but it never progressed. That's the value of the genetic resistance. In the face of a trial where Carolup lost 2 tonnes, the moderately resistant varieties basically had no response. Stem rust really is the granddaddy or the monster when it comes to rust. So this is stem rust in oats. Thanks, Trent, for these photos. And by the way, this isn't the before and after when Trent told the person not to spray. This is actually, so Trent sent me the initial photo, September the 20th, I think, or something like that, saying there's a little bit of rust, stem rust in this banister. Banister's moderately susceptible for stem rust. and talking about thresholds and things, and obviously the advice was to spray this crop. The second photo is about 3 weeks later. So again, just showing the damage that can occur from these rust diseases if they're left unchecked. Just quickly, stripe rust. So I've got an old photo returns. We haven't basically had a report to pest facts of stripe rust since 2015. Okay, so this year out in the eastern wheat belt, Kalingari and Chief, which are both susceptible varieties, we started to get late season reports of stripe rust. And those pictures are from paddocks of Chief at Narrabeen this year. The pathotype, so we were a bit worried. Speaking with Robert Park from Sydney University, he was a bit worried because they've had a number of new incursions of stripe rust in the eastern states, and obviously we don't want to have some of these new incursions which might end up with the majority of our varieties becoming susceptible. Luckily, on our front, it turns out it's just the old WA pathotype. But the interesting component of this is, I don't know where the hell it's been for the last 5 years. But it does just hammer home the importance of that green bridge message. Okay, so we had, and particularly at least one of these properties, retained green material from last year of a susceptible variety for sheep feed, obviously then acting as a green bridge, resulting in this build-up of disease. Just an advert for the decision support apps. If stripe rust becomes an issue next year, then there is stripe rust WM available, which much like the canola apps, does the same job. So I just want to finish off by saying that, obviously we heard about the soft finish to the year. We've had green material, green regrowth, frosted crops cut for hay and green regrowth. We're shortening that period between the end of this year and the start of next year, basically. So we've seen that rust is built up this year off a series of no rust years. So I would suggest that if Ian gives us a wettish summer and a wettish start to next year, that rust is something that actually we are going to need to keep in the back of our minds. And I just wanted to remind you the importance of those diseases in terms of their impact. Cheers.